Alright, we're adding aqueous solutions here, and we're going to add equal volumes of solutions, and this is the only possible combination for both of these, only possible insoluble salt that would form from this for either of these two problems. So we're going to be looking at the solubility of barium carbonate. Okay, so the other thing I want to mention is going to make our calculations easier is if we think for a second here, we know that if we had 200 milliliters of each, and it could be any volume as long as they were equal, and then are added together, our total volume at the end is going to be double in size, which means the ion concentration of each is going to be cut in half. Alright, so we don't have to worry about doing those calculations. This will save us some time when we're calculating a new ion concentration. So what we're doing is we're trying to determine whether or not barium carbonate will form, and it will if IP is greater than KSP, then our barium carbonate will precipitate. So let's calculate our new ion concentrations and calculate IP. If we look at barium carbonate, we know we're going to get barium ions and carbonate ions in solution. So our KSP is barium times our carbonate ion concentration. So what are our initial concentrations of these ions? Well, the barium is going to come from the barium chloride. So it's going to be the old concentration divided by 2. Chloride ion concentration, mu, is going to be, carbonate ion concentration comes from the sodium carbonate, and the new concentration in the 400 milliliters is going to be the initial concentration cut in half. Alright. So our KSP is equal to 1.5 times 10 to the minus 2 times 1.0 times 10 to the minus 3. Actually, to be more accurate here, we are calculating the ion product, not KSP, because we don't know if we're at equilibrium or not. Alright, so our ion product is equal here to 1.5 times 10 to the minus 6. And if we compare it to KSP, which is 2.6 times 10 to the minus 9, we find that IP is greater than KSP. So the precipitate of barium carbonate will form. Alright, this next solution, the barium nitrate and sodium carbonate again. So our ion product is going to equal the barium ion concentration times the carbonate And we're going to skip right to it because we know that these concentrations are going to be cut in half. So the initial barium concentration is 1 times 10 minus 5. We cut that in half for the new concentration. Same for carbonate. And we find our ion product is 1 times 10 to the minus 10. So IP, this is equal to IP. In this case, we compare it to KSP. We find IP is smaller than KSP. So no precipitate will form.